Alright, today we are starting chapter 3. We are going to be transforming equations using addition and subtraction. So really, we're just going to solve equations today using addition and subtraction. Here are some warm-ups. So notice that these are not equations. We do not have an equals sign. So all you're doing is simplifying or combining like terms. Number 1. Connie, what did you come up with? Okay, so what do you think we can combine on number 1? The 6's, right? One of them's positive, one of them's negative. One of them's plus, one of them's minus. So when they combine, what does that equal? 0, so what are we left with? X plus 0 or just X. Very good. Alright, number 2, Jamal.
Oh, me?
Yeah. Very good. So we just get T on number 2 because, again, minus and plus of the same number zeroes out. Number 3. Kelby, what'd you get?
X.
Just X. Again, we have positive 2, minus 2. So a positive and a negative of the same number, those zero out. We're just left with X. Even though they're not right next to each other, it's the same thing. Adrian, what about number 4? Very good. We just get R. The negative 4 and the positive 4 cancel each other out. Alright, number 5. Anybody get number 5 or think they got number 5? Lexi?
Yeah.
Close. Anybody get something different? Jaquan? Negative M. Very good. So the 13 in the front and the minus 13 in the back zero out. But this M is negative or minus. So we have to keep that sign with it. All the other ones were positive, so we didn't have to worry about it on any of the other ones. The addition property of equality states that if A, B, and C are all real numbers, and A is equal to B, then A plus C is equal to B plus C. So we just added the same thing to both sides of this equation that they gave us. We added C to both sides. So they want us to show an example where we have A equal to 2 and C equal to 3. So if A is equal to 2 and A is equal to B, then what is B going to equal? 2. Alright, A equals 2, A and B are equal, B must also be 2. So when we go to plug this in, we have 2 plus 3. So plugged in 2 for the A, 3 for the C, equals, we already talked about we're going to have to plug in 2 for B, plus 3. What is 2 plus 3? 5. So 5 equals 5. So if A and B are the same thing, we can add the same number to both sides. The subtraction property of equality states if A, B, and C are real numbers and A is equal to B, then A minus C is equal to B minus C. Once again, we're just subtracting the same thing from both sides of this equation. And again, if A is equal to 10 and A is equal to B, then what must B equal? 10. So we can start plugging things into this general form we've got up here. 10 minus 2. I'm also plugging 10 in for B. 10 minus 2. Again, what's 10 minus 2? 8. Wonderful. Remember the golden rule for equations. Whatever you do to one side, you must do to the other. Our steps to solving equations. First, box the variable. So you need to know what it is that you're focusing on. So we're going to box in the variable. Our goal is to get it by itself. Draw a line through the equal sign. So that way you can tell what your two sides of your equation are. Complete your algebra on both sides of the equation. And finally, box or circle the answer so that I know where you stopped. Alright, so let's follow those steps. Step 1, put a box around my variable. So I'm trying to get x by itself. Draw a line through the equal sign. Now if you want to do a solid line or a dashed line, that's up to you. I like to make mine nice and long. Do the algebra on both sides of the equation. So when we are getting a variable by itself, many of you may remember that we have to do the inverse operation. So instead of subtracting 6, Keon, what would we do? Add 6. So our goal is to do the inverse operation. So we add 6, but if we do it on one side, we do it to the other. So I'm going to add 6 on both sides. Alright, now when we add 6 to a minus 6, what happens? Cancels out, it's a 0. So that's just kind of gone, right? We can cross it out. So we're left with x equals, what is 9 plus 6? 15. This is when a calculator might come in handy. Maybe not necessarily on this problem, but if we're using positives and negatives, sometimes we struggled with that. And so I'm going to rewrite it below the dashed line and circle it for my final answer, x equals 15. Alright, number 2. This time my variable is a y, so I put a box around that. I put a dash through my equal sign so I can tell where my two sides of my equation are. Houston, what do you think I need to do next? Well, I want my variable alone. Right now I'm adding 7 to my variable. So what's the inverse of adding 7? Do what to both sides? We want to undo adding 7. So what's the opposite of adding? Minus, subtracting. Okay, so you're right, we do want to do it to both sides, but we're looking to do the opposite of what's going on, the inverse. So instead of adding, we are going to subtract 7 from both sides. You can add 7 to both sides, it's just not going to get your variable by itself. Right? So it's not very helpful to do that. So when we subtract 7 from both sides, we get y equals 3. And then that's it. Y equals 3. That's my final answer. If you're not sure if you got the right answer, plug it back in. Go back up to the top and say, instead of a y, I'm going to put in a 3. And I'll ask myself if it comes out correctly. Well, hopefully we all know, or we can use a calculator to tell us that 3 plus 7 is 10. And 10 equals 10. So that means I got it right. I checked myself. So if it ever says to check your work, or check your answer, check your solution, that's what it means. Take it, plug it back in, do the math, see if it comes out correct. Step 1, box my variable. Step 2, draw a line through my equal sign. Now I'm ready to start doing algebra. May, what do you think we should do? Okay. Very good. We want to get x alone. Whatever we do to one side, we have to do to the other. So we're subtracting 5 to undo adding 5. Those zero out. Jakeem, what do I get for x? Alright, so x would equal 4 in this case. Make sure you're paying attention to your operation. Again, if you have a calculator, I'd recommend using it starting today, just to help this go a little bit quicker. The question was, are we doing the same thing on number 4? The answer is yes. So I'm going to box my variable. My variable's in a different place. That's fine, I just had to find it. I'm going to put a line through my equal sign. And now for the algebra part. So this one's a little bit trickier, because we don't have a symbol in front of the 5 to know automatically how to undo that. We want it to zero out. And right now, is this 5 positive or negative? It's positive. So what do you think we need to do to make it become 0? Minus or subtract or make a negative. So to get rid of a positive 5, we're going to subtract 5. But if I do it on one side, I got to do it on the other side. Okay, so there go away there. I have x by itself equals 2 minus 5. Keon? Is negative 3. So I have negative 3 is equal to x. If you want to rewrite it as x equals negative 3, you can. Either one of these is correct. So you don't need both, you just need one of them. Box my variable, line through my equal sign. On this one we have a negative 4 next to the variable. Natalie, what do you think we're going to do to cancel that out to 0? Very good. To cancel out with a minus 4, we would add 4. That's going to make it go to 0. But if I do it on one side, you got to do it on the other side of that line. The other side of my equation. 0 plus 4 is 4. Y equals 4. On number 6, box my variable, line through the equal sign. Keon, what do you think we should do next?
Add 1.
Okay, good. I add 1 over here to zero those out, so I add 1 on the other side. So I'm left with r equals, what is negative 1 plus 1? 0. So that's it. You can have 0 as an answer. And we could plug it back in to check it. Negative 1 plus 0. Does that equal negative 1? Well, negative 1 plus 0, adding 0 doesn't change a number. So yes, we got it right. Very good. So once we get it set up, we add 2 to undo the minus 2, those 0 out, and we end up with 6 equals S. Or if you rewrote it as S equals 6, that would be correct as well. Alright, next group over, Jeriel, Keon, and Tariana. Number 8. I boxed my variable. I put a line through, then what did you do?
Added 9 to negative 9.
Good, so we should add 9 to both sides, right? Not just to one side. And we got t equals?
4.
A positive 4. Very good. All right, we'll keep on going. Next group over would be Carl, Natalie, and Delaney. So I am going to box my variable, put in my line. All right, group, what did we do?
Subtracted 5.2 from both sides.
Wonderful. And then what did we get?
We got 9.8 equals Z.
Positive or negative 9.8?
Positive.
All right, so it would be negative 9.8. Watch your signs. If you're not sure about them, get a calculator. I'm going to keep on emphasizing that. All right. Number 10. We'll go back to the other side of the room. Houston and May.
Subtract 26 from both sides.
Very good. We subtract 26 from both sides. That gets D by itself. So this one was a little tricky also. Negative 15 minus 26. What did we get? Negative 41. Very good. Again, you lost $15 and you lost 26 more dollars. That means you have lost a total of $41. If you want, you can do the change it into an addition problem by doing the copy, change, change. Okay, if we're adding two negative numbers together, we're going to add their values and keep it negative. Alright, Lexi and Logan, what did we do on number 11?
Add 4 to both sides.
And what did we get?
T equals 26.
Beautiful. Alright. Almost didn't circle my answer. We're going to keep it moving. Kelby and Jalen, what did we do on number 12? Good. We add 1 to both sides, and we get what? X equals negative 3. It sounds good to me. If you put negative 3 equals X, because you wanted to drop things down where they were, that's the same thing. That's fine with me. Alright, we'll keep it moving. Number 13. Let's go with this group back here. Jaquan, Adrian, and Ryan. What did we do?
Subtract 9 from both sides.
Very good.
You get R equals negative 23.
Wonderful. Subtract 9 from both sides to zero out that positive 9. Negative 13 minus 9 is negative 22. Looks wonderful. Number 14, Deja and Danielle. What did we do? Subtract 1.2 on both sides. And we end up with 2.6 equals y. I like it. If you put it as y equals 2.6, again, that's the same thing. Wonderful, wonderful. Number 15. Jakeem and Shannon, what did we do?
Oh, you add the 4.7. It would be equals y equals 2.1.
So I like the adding 4.7. I'm not sure about the y equals part. Alright, so we end up with a negative 1.3 when we add 4.7 to negative 6.0. Again, if you don't want to be working it out by hand, a calculator is helpful. Those were our notes. So now it is time for homework.